Hunter 811. It's a newer machine than my 611 that this one replaced, but it's dinosaur compared to this. And we got coming in the new John Beam machine. This is a great machine. It works really good. I like it a lot. The thing I don't like about this one is the way you have to comp the sensors. So when I mention comping the sensors, what am I talking about? What do you think I'm talking about?
Calibrate them.
Comp meaning compensate. I got to compensate for something. What do I got to compensate for?
Sensors.
Comping the sensors.
What sensors?
The sensors that I'm going to show you guys how to hang on to the car. So look, backtrack to spring term when you guys learned how to run the Pro Cut machine. What's a Pro Cut machine do when you first turn it on? You know, like click it and crap.
Balances.
Run out.
LRO.
So it's compensating for run out. Okay, so we're doing the same thing with this machine, except we're doing it manually. You don't have to do it with that machine because it's a fancier machine. These new machines take a picture. That's what this one does. See the big arms, the black arms? I call them vertebrae. We hang targets on the side of the wheels. Okay? On this one, we actually have to hang this big sensor. And the sensor itself is going to shoot a laser beam. The sensor is going to shoot to the back one, it's going to shoot to the front, and then this side one's going to shoot to the back, and we're going to have a laser beam going all the way, you can't see it, but it's going to be going all the way around the back and the front of the car, the sides of the front of the car. These new ones, especially the one I just trained on up in Lebanon, that's even fancier than this Hunter machine, they take a picture and they find the center of each hub on each wheel, the center of each hub, and they make a square, a perfect square. They take a picture of that perfect square, and they can figure out every alignment angle based on that perfect picture that they took.
Wow.
It's incredible.
So you can walk in front of it and it'd be okay, or is it still kind of cut
It's
out?
still got targets you got to hang on the wheel. It still has to see the wheels. So it can look at the adjustments that you make. But what that machine will do, when I was working with you on the Mustang, we talked about caster not being live, huh? Well, that's out the window now with that new machine
That'd be nice.
because of the way it's set up. And this one down here will almost do the same thing because it's always changed caster when we've been working with it, but I never trusted it. But we verified it up in Lebanon, and this one may do the same thing. But you can actually see caster while you're making adjustments. And typically on this machine, you can't see caster. Caster's always been a angle that you have to measure each time you get a reading.
And that's by
That's when you turn the wheel side to side. Okay? Camber's a live angle, toe's a live angle. Caster never has been, but now it is on the new machines. But I don't have it yet, so we're not going to be working
Is
with
that
it.
the
So
machine that we're getting?
it's on the way.
Oh,
It's
okay,
been
cool.
ordered. We're getting a new aligner. We're getting a new balancer, and we're getting a new tire wheel change. What about
Damn,
torque
we're
wrenches?
making
I
that
said
much
it's probably
money.
going to be like the torque boxes where you were told they were supposed to be here by a certain time. And wasn't
Well,
it like 2 terms later?
I hope not. They were just ordered at the end of last term, so we'll see what happens. I'm not that worried about it. Okay. So this is an older machine, but it works really well. And when you guys go into shops after you leave here, you could very well see something like this because not all the shops have these. Wild guess. Hawkeye, how much retail?
5.
Wild guess.
10, 20 grand.
5 grand.
Okay, put it this way. I'm a school, I get a discount. I got it for 22 grand. Keep going. Come on.
I was about to say.
About 35 grand retail for that machine. 30 to 35
Wow.
grand. And that was a couple of years
That's
ago.
a good down payment on a new truck.
So alignment equipment's not cheap.
No.
Now you could pick this 811 up. You could probably find one of these on eBay for a couple $1,000 probably.
Really?
And it's going to do an alignment just as well as that machine's going to do an alignment.
Yeah. Just
It's just
without
not as
hanging
fancy.
them all.
Exactly.
So you said compensating for the sensor, like you have to plus or minus a couple or what?
I'm going to show you how to do it. We got to compensate for run out in the wheel. That's what we're doing when we comp the sensors. So any run out in that hub has to be shown to the machine. We have to show the machine in your run out. It has to know there's run out there for it to calculate proper angles. That's why we comp the sensors. Okay? All right. Questions so far? All right. So I'm going to run you guys through comping this thing and getting it all set up. So the first thing we have to do, is quit playing with my stuff. The first thing we have to do is we've got to get the jack set on front and back. We've got to get the front end lifted up off the rack, and we've got to get the rear end lifted up off the rack. Okay, so let's go ahead and do that. I'm going to have all you want to go ahead and do is get the car put into the machine. So, Foster. Oh, Karina. She's going to do it. It's your truck. She just jumped right in there.
Who is Foster?
It's my truck.
He's Foster. You don't have to do that. You could have done it. I didn't care.
Well, he wants to do it.
Click past that. You don't need to put the customer name in. So that's
Okay,
a
it's
screen.
okay.
You could put the customer's name in there and print out a work order when you're done, but we're not doing that. So, all right.
Double click.
You can double click it or hit OK.
Jeez. Calm down. Scroll down.
All right. That's wanting us to measure ride height and stuff. Quick past that. We're not going to do that right now. We'll do that later. Okay, so what it's telling us right here is they want us to measure the ride height before we start. I haven't even got into the ride height with you yet. Ride height is typically a pre-alignment check that we want to be paying attention to, okay? Because if you've got a spring sagging on one corner of a vehicle, that's going to affect your alignment, isn't it? So ride height adjustments, and you can see we've got an adjustment right here. So turn anchor arm adjustments. They're showing you the torsion bar on this thing. And they're showing what you can do, because on a torsion bar, you can actually raise and lower the suspension a little bit. You can actually get about a ½ inch either way out of a torsion bar. If you hold now, I'll raise my truck. You go. So if you've got a ride height issue, then you could adjust it on this one with the torsion bar. That's what they're showing us right now. Go ahead and click OK again.
When you get into like the lifts and stuff, do you need to replace that?
Usually, you got to be thinking about it at least, because now you're talking about some different stuff that's happening in here. So, all right. So what it's showing us right now, and we'll get back into ride height later. There's a lot of elaborate different ways to measure ride height. You'll look on the computer and it'll say go from this spot to this spot between these two control arms and measure the distance between here and here. Or measure the distance between this control arm and down to the floor. Quite simply and quite frankly, this is not going to be accurate right now, but when the vehicle's set on all four wheels and everything's loaded, just check your distance between the top of the tire and the fender well. Just get a quick check. Stick a finger in there. Just eyeball it. If it's off and you've got a saggy spring, it's going to be obvious. You don't have to spend a lot of time getting your tape measure out and find all these different spots to measure right. It's just a waste of time. Does that make sense? Flat rate it. Look at it. Now, if you've got this sucker's down on top of the tire and the rest of them got 2 inches gap on top of the tire, now you know you got a problem, right? Now you got to go to your sway bar or your
You have to
torsion
lower
bar.
the other one down.
Well, raise the other one up or lower the other one down, whatever you got to do. Torsion bars don't go bad that often, so you probably wouldn't have a ride height issue very commonly on this one. Okay? Springs go bad. Okay? All right, so one thing I didn't mention before we get started here, I didn't mention the pins on the turn plates. So if you notice, these things are pinned. They're pinned because when they're at rest in this position, they're not supposed to be flopping around everywhere. We unpin them when we start making our measurements. Okay? This is a very important part of an accurate alignment. There's little Teflon balls in here, little marbles that go between this plate and this plate. And that's what causes it to be able to move around. See how it moves nice, and see how stiffy it is and stuff? That's pretty stiff. That's pretty stiffy. I need to have Margaret take these apart and clean them for me. Because you want to have a turn plate that floats nice and free, because when you sweep your caster, any kind of drag on that turn plate when you're sweeping your caster kind of shows up like this on your wheels, and it affects your reading you get on your caster when you're sweeping it. Does that make sense?
Yeah.
So your turn plates are pretty important. We always want to leave them pinned when we're moving off of the rack or moving onto the rack. I don't have you guys unpin them before we lift the car up, because it's a pain to get these pins out with the weight of the car on the plates. So what I'll have you do is once we get the sensors hung on there and we get them compensated, then we'll unpin the plates before we let the front end back down. Okay? Then we'll have everything where we need to have it. The plates on that rack down there are all air actuated. So I was talking to you about the compressor needing to be on before we pull stuff up there. Okay? Because alignment racks not only have turn plates in the front, but we also have slide plates in the back. And you'll notice these are pinned also. Because how many vehicles out there are straight axle?
Not a lot.
How many vehicles out there now have independent rear suspension in them now? And the vehicles that have IRS, there's usually at least one alignment adjustment back there that you can perform. And it's usually always toe. Okay, not always. Some of them actually have a camber adjustment too. You're never going to see a caster adjustment in the back end because there's no steering going on up there. But we'll always have a toe adjustment in the back end, and we could have a camber. And that's why we have the pinned slip plates. The John B. Lift has the same thing down there. Those are actuated by locking, air actuated locking mechanisms. That's why we make sure that you get air compressors on. Okay, so back over to our machine. We've got two different sets of heads on this thing. So we've got our front heads are hanging on the top, and our rear heads are hanging on the bottom. The difference between the two are the front heads have the beam that will shoot across the front of the rig. Okay, so we're shooting across to the front of that one, and then we've got this infrared sensor shooting a beam back to the rear sensor, so we basically got a square coming around the car, but not in the back end. See, that's where we get the advantage on the camera line. That's how it's better, because it gives us a more precise view of the
Even on
car.
the back tires.
They get a very, very, very much better view of the car, okay? One other thing about this machine, and this is a very important part of this machine, okay? This machine has two different on and off switches on it, okay? Can everybody see this light right here? The little green light? That means the head is charged, okay? So this area right here where the head hangs, there's a little electrical contact in there. And when we hang these heads back up, it makes contact on that charge port that's right here. And that's what charges our head, okay? So if we turn a switch off on the machine, it needs to be that switch after we've shut the computer down, just like you do any other computer. If you want to turn it off, you don't have to. Just exit the aligner, it'll shut the computer down, and you don't have to turn the switch off. But if you wanted to turn the switch off, that switch is the one to turn off. There's another power switch on the back of the machine. If you turn that one off, it kills the charge heads. So never turn that switch off, never unplug the machine, hence the reason the plug's that high. Because I had students kept unplugging the machine because they needed to plug their little drop cord in or something like that. Even after I told them, don't unplug my alignment machine. And I come here and damn things unplugged and they just dangle. Then I get pissed, start screaming and shit. I don't like being like, mean Pete don't need to come out. He doesn't want to come out. He likes to be nice Pete. So that's why that's up there. So a couple terms ago, it wasn't one of you guys. It was one, I don't remember who it was. Maybe it was last year. Over here on a stool. Who's ever heard of a stool? Standing on a stool, trying to get to the...
I tried too.
I walked over there and the kid, you did. I said, do you think there's a reason that the rest of these plugs are as low as they are and that one's up higher? Do you think there might be a reason that that's the case? And I said, yes, the answer is yes. There is a reason that's... Stick it down off the stool.
It wasn't me.
Well, I'm trying to
I
get
did
to
that
it
one for
so I
that
can
one.
charge my phone.
I don't remember who it was.
I was about to say,
It
I
might
have
not
to
even
get
have
on
been
a
your
stool
group. It
for
might have been
any
a
of
group
these.
last year. Who knows? But up on a stool, I walk around the corner. He said, "What's wrong?" I'm holy fuck. Are you kidding me? Okay. Next thing about this machine. Questions on the switches.
So turn the
Okay,
one
turn
on.
off. Not okay, turn off.
All right.
Okay, turn off. Not okay, turn off. Pretty simple. All right. All right. Okay. Okay. Next thing, what we're showing right here is sensor is not connected or is not turned on, and it's not. So we got to hang the sensors. Okay, so that's what we're going to do next. BB, I'm going to have BB show you and talk to you about, because he's an expert. He did an alignment for me last summer, so he knows how to hang the sensors. He's going to talk to you about making sure that they get into the rim good and solid.
Good and tight.
Go for it, BB.
Okay. So you nice and easy. Take it off here. Go over here to the front tire.
Oh
here.
yeah, and by the way, while BB's going, how much you think one of those heads costs?
A lot of money.
About
$1,200.
$1,000. You're right, about $1,000. And this is a 30-year-old alignment machine. Okay.
Oh God.
So you find the edge right here, and you go down.
How old did you say this line machine is?
About 30 years.
So you push in the top. Oh, this one's kind of weird here. There we go. So nice and tight.
Yeah, keep pushing. There you go.
Tying down. Go to the bottom.
There you go.
Tying down.
Stop, BB.
Press in.
That'd be awesome.
Do it one more time on the bottom. Pete doesn't like doing that, but you know, it's okay. So you pull on it. It's good. Don't forget the little safety here, which won't do nothing.
I'd like to see that one a little farther, BB.
Which one?
This one.
In?
Yeah, when you wiggled it.
There you go. There you go. Now snug her down good and tight. Put your man hands on that sucker. That's what I'm talking about. And then, like BB showed you, you're going to go ahead and give it a little tug. And don't be sissy with it. Give it a tug. If it's going to come off, you want it to come off in your hands. Okay. And then, and I'm not a big fan of these hooks on these things. The older machines that we used to have had a safety that screwed to the valve stem on the tire, which you'd think is a little bit more foolproof, but it's not.
No.
We had one fall off one time, and
And
guess what
rip off
happened?
the valve.
The valve stem ripped right out of the tire, and the head still hit the ground.
Should we comp it, or do we need all
Let's get them all
sensors
four
on?
hung first. Okay, so I'll let BB do that one. Let's go ahead and have somebody grab one of the other front ones. Let's get another front head hung. Looks like you're starting doing some things. We'll get one turn on. Both lights will come on, and that red light will go off, and that green light will stay on. Okay? We're ready to start compensating these things now. And if you notice on the machine, it shows the left front sensor just needs compensation now instead of being turned on. Okay? All right, so when we compensate, first thing is we want to make sure that our little lock is disengaged. This is a lock that we can lock the sensor with. We can unlock it and it'll move, or we can lock it down and it stops the sensor from moving, okay? So, when we first start doing this comp procedure, we want to go ahead and take our top button now, and we're going to hit it twice. What's going to happen is that green light's going to go out, and the red light's going to start flashing, just like that, okay? Now, I'm going to come to my wheel, and I got a rag in my pocket, and I'm going to rotate the wheel. So on your sensor head, you notice how it says 1, 2, and 3? Everybody see that? We're right now at position 1. We're going to turn this wheel to position 2. Okay? So I'm going to turn it around and I'm going to watch for position 2 to come on, and when I get there, I'm going to get a green light. Just like that. Okay? Now, I'm going to go ahead and level my bubble. Everybody see the spirit level in the top of the top of the head?
Yeah.
Okay, so what we're going to do is level that bubble and hit the buttons. But to level the bubble, instead of trying to chase that bubble all around, I like to snug the lock down a little bit. And you can usually get the bubble pretty close, just like that.
Yeah.
That way the head's not dancing all over the place on you. Then you're going to level it, get the bubble in the middle, hit the button once. Red light should go, or green light should go out, red light flashing still. Unlock the sensor. Now we're going to run it around to position number 3, and we're going to get one more green light. And we're going to snug, level the bubble, button once. Should stay both lights on, should get a green light on the machine. Sensor's now compensated. Unlock the sensor. Don't forget to unlock the sensor. Okay? So let's get them comped.
Get to unlock
Okay.
the sensor.
What do you think?
Fix the camber on the left or the right, because that's way.
Baby, didn't I just hear you telling somebody not to pay attention to those numbers? Why don't we want to pay attention to those numbers before we even talk about
We have-
anything else?
We haven't jounced it yet.
Why do we want to pay attention to those numbers?
I think because we haven't jounced it yet.
We haven't jounced it yet.
That's not the whole reason.
Because we haven't adjusted anything
The
yet.
main reason is the damn thing's hanging in the air.
So we need to lower it.
Okay? Don't we need to look at our alignment angles with it loaded on the wheels?
Maybe.
Answer is yes. Go ahead, say yes.
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 Yes, please. Yes, please.
Yes, Pete.
Okay, so our next step then is to go ahead and lower the vehicle down on both ends, and we're going to jounce the vehicle. You can do both at the same time if you want. Now, on the front, before you set the weight of the vehicle down on those turn plates, let's pull the pins out. That way we can do it. Set it down.
For accuracy.
That's good enough, Alan.
Because the truck isn't gonna ride up like that.
Okay, so you're settling everything, right? Because when you lift something, especially, now we had this one lifted by the suspension, so it didn't relax that much. But usually if you lift something by the frame or something like that, the suspension relaxes. Meaning that your camber can go negative, or a different type of suspension, it can go positive depending on what it is. So you always want to set it back down and jounce it, so you're looking at accurate numbers there. Otherwise, you're not looking at accurate numbers. Okay? Why don't you go see Nikki?
Okay.
You can prove the register. Probably right. Talk. All right, so what we're looking at here is camber. We're looking at toe. We're not looking at caster right now, because what did we say about caster earlier? Unless it's the new John Bean machine. It's not live. We have to actually measure caster. So in order to measure caster, we're going to run through a procedure called a caster sweep, where we're going to actually measure the amount of caster in the suspension. The machine, this older machine, when we do a caster sweep, actually measures the change in camber as you're running through the caster sweep, and it determines caster off of that. Okay, so when we do the caster sweep, you can see the camber changing. Well, look at Alan's camera; it's badass. Alan, look at that, right on the money. So on an alignment machine, if the numbers you look at are green, that means that it's in specification. So we put this vehicle into the machine, and the machine has the specs for the front end for this vehicle programmed into it.
If it's stock.
If it's stock. Good point. So we'll talk about, and we should talk about it, I don't know if the guys that are doing the class for me will say this, but all green is not always what you want. Okay, did we have all green on the Mustang, baby? No, we did not.
I think we got one green.
Yes, because many times you're modifying something, you're aligning something that's been modified. Let's say you've got a big truck sitting here, and it's got 35s on it, 10 inches wide, 8 inches wide. And factory camber for that truck, let's just say it's a 1/4 degree positive. Okay, so a 1/4 degree of that tire tipped out. So if I've got an 8-inch wide tire, 35 inches tall, am I going to want to put 1/4 degree positive camber in that tire?
No.
No, because I'm going to wear the crap out of the outer edge of that tire if I do that. So in that application, we're going to want a 0 degree. Now, and it may be still in spec because they give you a parameter, a tolerance, so it still may show up green. But if we set that camber adjustment to 0 and it shows up red, we don't care because that's where we want it. Yeah.
So if we get bigger tires on, how would you measure what
Yeah, how
you
would you
need
know?
to put it at?
It's a pretty safe bet to say if you've got anything larger than factory tire on there that's a decent
Just
width on
put it
there,
at 0?
you better be setting it to 0 camber
Okay.
because it's going to wear the tires if you don't.
Okay.
Simple as that. Okay, so that's an instance where all green is not good. Okay, all right. So what they're showing us here is our left camber, our right camber, and the number in the middle here is called cross camber. We'll also see a number down here for cross caster once we sweep caster. So cross camber, cross caster, and total toe for that matter are basically the sum of the difference between the two labels. It's the simplest way to explain that. So because our camber adjustments are even on both sides, our cross camber is 0 because we have no cross camber. If I had 3/10 here or 2/10 here, I'd have 0.1 for a cross camber. There's a spec for the cross camber also. It can be bad or it can be good. It just depends on every vehicle. Okay, so Alan's camber's in good shape. His toe is a little bit off, but it's not too bad. So if he's negative toe on the left side, is that positive or negative toe? He remembers. Remember my little trick I did in the classroom this morning? Well, it'd be positive
Negative
toe with a negatively.
Which one's toe? This
Negative
way?
camber. If
Yes. Yeah.
Toe is here. Front
Negative.
tires. Distance between the front and the rear, distance between the front
Think
and
of
the
your
rear.
toes. You
Negative
can turn
out.
your toes in, you can turn your toes out.
So that's toed out. It's negative.
That's positive. right?
positive
Or
camber.
toe in is negative, or toe in is positive, toe out is negative. So
Yeah.
if it doesn't show negative, it's a positive angle. So that's why that doesn't show a plus sign next to that 11/16.
that one-
So that's a positive toe we're looking at. This is a negative toe.
So this left one's out just
Yes,
there.
and this one's toed in a little bit.
Well, if you look, yeah.
So this
if you
one's
look
like
at
this,
it-
So you
and
go
this
down the
one
road
is
like
like
this.
Okay.
Make
Yeah,
sense?
you got one in, one
Well, you
out.
want out. So
Wheels
you're
are like
going.
slightly to the
You're going.
left. Wait. No.
Yeah.
It's the other way.
So negative's toed out.
Do that again.
Okay, well, yeah, here, negative's toed out, so
got it,
left toe
video.
out. And then we're toed in here.
You gotta send me that. Look at that tongue.
There's my retard stance.
Oh my
Now
god.
if we're both toed in, here's what we did.
My coach
That's
was like
called pigeon
that.
walk.
My coach was like that.
Is
Pigeon
he?
toe.
Pigeon toed? What's this called?
Duck toe.
Heel?
Duck feet.
Is
Duck
that-
feet.
That's duck feet?
Yeah, because you're walking out like a duck.
Quack, quack, quack.
All right. So, and also what we're looking at on Alan's toe is his total toe is okay. Okay, so total toe, again, total, it's the sum of the difference between the two sides. So there's going to be a spec for total toe on this thing, and it's in spec at an 1/8 inch. And that's the difference between the two sides. Will we leave it like that? Probably not.
Why?
Because typically you want to have toes pretty close as you can get it. And I'm not happy with toe if I've got any red readings in here. Because toe is something you're not going to deviate from usually. Whether somebody's modified a suspension or not, toe is going to be the same. You want to have toe set where it needs to be. Okay?
But it said it's okay, but you still want the green tires, the green?
Yeah, I would
red
probably
tire
adjust this a little bit more and try to get the side-to-side toe a little bit closer. Because I don't know how far off that is from the spec. We'd have to pull the specs up to look at it, which you can on the machine. We can go, I'll show you some of the different stuff in a minute that it can do, but the little action boxes in the middle here, we go vehicle specs. Now it's going to bring up all the specs for us. So here's our camber specification. So it's a 1/2 degree positive. Again, if it doesn't have a negative against it, it's a positive reading, okay? So 1/2 degree, and then 1/2 degree, and then we have a 1/2 degree tolerance. So that's why we're in spec at 2/10. Make sense?
Yeah, because it's not 0.5.
So it wants a 1/2 degree, but it's not a 1/2 degree away from it. So if we were down closer to 0 toe, or on the other side of 0 toe, then we'd be red on that reading that we were looking at, huh? Because we're past our tolerance. So that's what that means. Here's caster, and this is interesting because usually 4-wheel drive vehicles like a little bit more caster into it than that. Probably because of the type of the suspension it's got. It does got the SLA suspension, so it is pretty stable already. But 1.5 degrees of positive caster, again, because it doesn't have a negative sign against it, is what they want on both sides of this vehicle. Many times, we'll see a different caster reading between side-to-side caster. Can anybody remember why that might be?
Isn't
What did
that
we
your
talk about
turning?
compensating for?
Isn't that
Wasn't it
turning?
for the
Directional
road crap?
drivability or something.
Wasn't it the road?
We talked about
Oh, yeah,
compensating
the
for
road.
road crowd, and many manufacturers will actually give you that specification. Okay, so if we were going to compensate for road crowd on this vehicle, and we wanted a degree and a half on the left, and we wanted to make it kind of try to pull to the left a little bit, what would we do?
Ghost.
Weed.
Okay, so we got a half a degree difference is what we're looking at to make a pull, right? Okay, so if I wanted to compensate for caster with this one, and I was going to set my left caster at a degree and a half, what would I want to set my right caster up at?
Negative.
A degree.
Do I want it to pull right? Remember, caster pulls to the more negative. Or did I forget to say that this
No,
morning?
you said that.
Did I say that?
I
I
thought
thought I
you said
did.
more positive.
That's camber.
Oh, dude.
Camber pulls to the positive because the tire's leaning out. Caster will pull to the more negative.
Which one's caster?
Caster's the one where we're
Caster's
changing that
this one.
steering line.
Your
That
heels
pivot
ready
line.
to.
Yeah.
Think about
Remember your chopper rake?
toe and camber.
Don't ever do that again. Toe, camber.
So camber's our tire at the top, tipped out.
Yes.
And remember, who's got a piece of paper?
Is caster the one where you're rotating like this?
The strut, you're rotating the strut
Yeah.
like this. Yes.
Okay, so
Why do you
I'm
look so
just using an SLA for example. So here's an SLA suspension, ball joint. We're looking from the side of the vehicle right now.
Okay.
Here's our center line down through both of those ball joints. Now if I take that center line and if I pull it back this way and do like that, I've just tipped that back and I've made positive caster. If I do the same thing and tip it forwards, now I've made negative caster. Okay? Caster is the tip forward or back of the steering axis.
So if you're looking on the side
Yes.
and it's going to the front of the car,
That's positive
Negative.
caster.
that's positive.
That's positive
When it goes
caster.
to the back, it's negative.
No, that's the opposite.
Positive caster is to the back.
Okay.
Okay, so if this was the rear of the vehicle, this would be positive
Positive or
caster.
negative, yeah.
This is the front of the vehicle, this would be negative caster.
Okay.
Okay?
So the front is negative.
Yes.
And this is in our book too, right? Like,
It's in your book
okay,
too.
cool.
And it's all over that handout I just gave you, and we're going to be talking about it more.
Okay, cool.
Caster's a very important angle, okay, because it does give you, like I told you in the class this morning, it does give you your directional stability, it gives you your returning ability to the steering wheel, and that's important for customers. People like to be able to go around and turn, let go of the wheel, and it comes right back. Okay? Caster does that for you. Okay? All right. So, and then here's our total toe, or our toe specs. So we've got an 1/8 inch side to side toe, and then our tolerance is a 1/16 of an inch. And you notice it doesn't give you a total toe spec down here, but it's going to take total toe off of that 1/8 inch side to side. Okay? So if we get anywhere around that, and our total toe is within that measurement, our total toe is going to be in good shape. Okay? All right, so from here we can go back to measurements and adjustments. Let me show you a couple other screens that we can get to do adjustments off of. One of my favorite ones to adjust off of is the bar graphs. And where do we get the bar graphs at? That was my, especially when I'm making like adjustments on toe. I like to, this machine's dumb. You gotta be in you gotta be in the virtual view. This is the one you guys always like when you fire the machine up. It's like a video game type of thing. Virtual view. And this is a cool machine because it kind of shows you drastically, it shows you drastic exaggerations of the angles and stuff and where you're at. So you see where it's showing your toe, toed out, toed in. You're not that far out, but it's showing you an exaggerated view of it just to give you an idea of what it's all about.
It's too scary.
Yeah.
So you're like,
So from this screen, we can go to bar graphs.
oh
And
yeah.
I like the bar graphs when I'm making adjustments, when I'm making camber adjustments and toe adjustments, because it gives you that arrow. And you can see right here, when you get closer to your adjustment where it's supposed to be, your arrow turns from an X to an arrow, and then it gets into the middle right there. It's just a lot easier to see when you're working it. Wake up, Alan. This is your truck we're talking about. You should be interested. Maybe we need to stand up, mister. Hey. Okay, so that's our bar graph screen. All right, now we can get back up into our screen we was in before. And I like this screen too for doing a lot of different stuff because it does show you your rear stuff a little bit better. Here's all of his rear angles back here. Nothing's green or red because there's no adjustments back there. So we've got negative, little bit negative camber in the back end. Who knows, saggy spring. Anything can cause that. Thrust angle is another angle that we want to be paying attention to. Thrust angle is the straight center line. Let me go back to virtual view and I'll show you that a little easier. So thrust angle is the center line down through the center of the vehicle. So thrust angle is the same thing, and what they're doing is they're taking a center line right down through the middle of that vehicle. Okay? When I was talking earlier about dog track and trucks you've seen down the road, that means that rear axle shifted a little bit on the thing, and it's messed up the center line. Okay? The thrust angle screwed up, and it's really hard. If you've got a truck, if you got a pickup truck like this with a solid rear axle in the back of it that don't have any adjustments back there, but you've got something that's switched or shifted on a spring pad, that rear axle's shifted on you, you're not going to get the front end to adjust right until you fix that thrust line issue in the back, and there may not be anything you do. We've hooked up the rigs with come-alongs before to try to pull that axle back so we could align the front end. Because it really, everything that happens back in the back affects the front.
Right.
Because it's, you know, it's right there together.
What's the thrust angle?
The thrust angle is the center line straight down through the middle of the vehicle.
Oh, okay.
Okay?
I didn't know that.
Really comes into play when we've got a four-wheel alignment going on. If we've got a four-wheel adjustable vehicle and the toe's out in the back end, that's going to throw your thrust angle out too. So when we're adjusting vehicles that have rear adjustments, we always start in the rear and move to the front. Never do your front adjustments first and then do the rear.
And that's not with a straight axle?
No, because there's no adjustments back there.
Right, so what?
So this one right here, his thrust angle is only 1/10 of a degree. He's fine. It's negative, so it's thrusted over, I think it's the same as, no, it's the opposite of toe, so it's thrusted over to the passenger side. But it's only 1/10 of a degree, so it's not that big of a deal. I've seen thrust out all the way up to like 10 degrees.
So thrust
Because something was
is this way would it be
Negative thrust is thrusted to the passenger side. In other words, that line is shifted to the passenger side of the vehicle, and positives is shifted to the driver's side of the vehicle. And that's not that big of a deal. You don't have to worry about that. Okay? Just know that if you look at this number and your thrust angle is 2 degrees, 3 degrees, 4 degrees, you've got an issue back in the back. Okay? If it's a four-wheel adjustable vehicle, you've got some issues in the back still too, and that needs to be dealt with. Okay? So always rear first, always toe last. Even if we're just adjusting this one, we do camber caster first, and then we finish up with toe, because toe is always last. Okay? All right, so the next thing we'll do is go ahead and do a caster sweep. Come on up here, Ellen. You need to get some movement going on yourself here. Get worked up. Okay, so measure caster is what you're going to click. All right, so let me show you this real quick. Go ahead and select measurement. Okay, so there's a couple different ways you can measure caster. The machine automatically defaults to this one. That's why it's highlighted. Caster and SAI and included angle. So I talked about SAI a little bit this morning, steering axis inclination, okay? And it works with camber, okay? And then there's included angle that also works with camber and caster. We can actually measure that when we sweep the caster. We don't ever usually want to just measure caster. We always want to know what the SAI and the included angle is. SAI and included angle are not adjustable. They're designed into the suspension from the factory, and they're not adjustable, but they are used as a very, very good diagnostic tool. We'll talk about that a little bit more after we get it up there on the screen.
What's included angle?
Included angle is camber and caster, or camber and SAI. That's